Welcome to qnawire.
So this question tells us that calcium crystallizes at a body-centered cubic. And the first question is, how many atoms are there per unit cell? And so that is just 2 calcium atoms per unit cell. And that is because it is a body-centered cubic. B is, how many nearest neighbors does calcium have? And that answer is 8, again, because it's a body-centered cubic. And now C gets a little more complicated. So for C, I'm going to draw what this cubic unit cell would look like. Okay, and now the radius is from one corner to another corner, and that is 4r, or that is the distance from one corner to another corner. The distance across here is going to be a radical 2, and this distance here is going to be a. And so we want to find a, or the side length. And so to do this, this is a triangle with a right angle here, so we can use Pythagorean theorem. So we have 4r squared equals a squared plus a radical 2 squared. And so then we'll solve this a little more. 16r squared equals a squared plus 2a squared. And so therefore 16r squared equals 3a squared. So now we know that, I'll draw an arrow over here, we know that 16r squared over 3 is equal to a squared, and therefore a is equal to radical 16r squared over 3. And so therefore a is equal to 4r over radical 3. And so if we plug in our r value of 1.97, we get that a is equal to 4.55 angstroms. So that is our answer for the side length. Now moving on to letter D, we want to find the density. And so density is mass over volume. And so first we'll find the volume. So since A is 4.55 angstroms, that's equal to 4.55 times 10 to the negative 8th centimeter cubed. And so, or not centimeter cubed, just centimeters. And so if we cube A, we'll get the volume. And so that's going to be 4.55 times 10 to the negative 8th centimeters cubed. And that equals 94.2 times 10 to the negative 24th centimeter cubed. So now we just need to find the mass, because we have our volume. And so the mass is going to be the molar mass of sodium, 40.028, or sorry, 078 grams per mole, divided by Avogadro's number, 6.022 times 10 to the 23rd atoms per mole. And then we have 2 atoms total per unit cell. And so we get our answer to be 13.32 times 10 to the negative 23rd grams per unit cell. And that's what we want. So we have our mass of the cell, we have our volume of the cell. So our density is going to be equal to 13.32 times 10 to the negative 23rd grams divided by 94.2 times 10 to the negative 24th centimeter cubed. And we get our answer to be 1.41 grams per centimeter cubed. And that is our density.